Good morning, guys. Today we're going to look at integrating exponential functions. So something like this even, where we have 2x e to the x squared. So it's actually a product of two different functions, but the e is to the power of another function. So we'll start off pretty easy and then work our way up, okay? So we know the basic exponential function. If I say d by dx of e to the x equals e to the x. If I differentiate e to the x, I get e to the x. So the integral of e to the x dx equals e to the x. If the derivative is the integral is the same. And don't forget the plus c. Now that's the first basic thing. If I integrate my exponential function, e to the x, I get the same thing out. Now we can look at a linear type, when we have a linear function in the exponent, like these two here. Okay, if I take d by dx of e to the some linear function ax plus b, if I differentiate that, the derivative of that top function pops out, which is an e to the ax plus b, and we know that from the last lesson. Okay, now I can say if that's the derivative of that, then that's the integral of that. So the integral of e to the ax plus b dx equals e to the ax plus b plus c. Now, remember I can drag constants through. So I'm going to take this a, drag it out, and divide through by it. Or the integral of e to the ax plus b dx equals 1 on a e to the ax plus b plus c, where that c is, the a is sucked into that c when I divide by it. Okay, so this is my second one. Now I'm just going to use these two before we get on to a more difficult case, which is if we have e to the f of x, any function, not just linear. Okay, and it turns out at this point we need it sitting like that, but I'll get onto this later. That'll be a bit more challenging. Okay, let's hold those in the screen so we can see them. We'll go, all you got to do is jump straight in, guys. Equals, you can see up here, the a comes down the bottom, that stays the same. Equals e to the 3x plus 2 on 3 plus c. Voila. Definite integral. We could say, well, that is equal to e to the 5x, or e to the 5 minus 2x on minus 2 from 3 to 2. Subbing in my 3 and my 2, I get e to the 5 minus 6 is minus 1. Minus, on minus 2, minus 5 minus 4 is 1, e to the 1 on minus 2, and I could take, that's about it really, isn't it? But I could say that that would become half e, that second guy, because the negatives will cancel. Sorry about that. E, and then that will become a minus 1 on e, and that might be a nice way of writing that. Okay, so now we'll get on to that more tricky case where we've got a function. The first way we're going to do this is to see it set out. Now this is an easier type question, maybe an advanced, but it's quite common. You should know how to do it. First, it says use the chain rule to differentiate e to the x squared. This is going to set us up for our more general case in a bit, okay? E d by dx of e to the x squared equals 2x e to the x squared. Alright, hence find the integral. Well, that's okay. B, just as we were thinking before, if that is the derivative of that, that is the integral of that. So the integral of 2x e to the x squared dx equals e to the x squared plus c. Why is this result obvious without any calculation? Because it is. Alright. What have we got next? Right. I want to now, let's jump straight down to this guy. This is the thing that I want you to get out from today. Let's bring that down a little bit. Right. If I have the derivative of a function that is in the e, if it's in this form here, I can jump straight to the answer. Now, the proof is the exact same as we've done before, probably not necessary, but d by dx of e to the fx equals f dash x e to the fx. If that's the derivative of that, that's the integral of that, blah, 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 blah. The integral of f dash x e to the fx equals e to the fx plus c. Right, so we've got it like that, okay? That's great. Let's just jump straight up to examples, straight down to examples. And these can get a little bit tricky, guys. We're opening up the world of things we can integrate. So, let's keep that in our screen so we can do this. Without stepping it out the way that they did in that previous example, we can jump straight to the answer. I want the integral of these, okay? dx, integral dx. So, I want it in this form here. I want the derivative sitting out the front. What is the derivative of x squared? If I take that and I say, well, if that's d by dx of x squared equals 2x. I want 2x out the front. I don't have 2x out the front, so I make 2x. If I times by 2, I divide by 2, and then I can just jump straight to the answer. E equals a half e to the x squared plus c. Cool? Alright, this one here. If I take this here, well, that's the derivative of that is 2x. 2x. What do I have? I have 4x. So, I want to make it a 2. So if I divide that by 2, I'd have to, so I'll write it again down here, okay? Integral of 4x e to the x squared minus 7. I want to change that to a 2. So I divide by 2. If I divide by 2, I have to times by 2. Equals 2 side of 2x e to the x squared minus 7 equals my answer 2 times e to the x squared minus 7 using this form here. Another way to do this one, exact same way really, but just dragging that 4 out. I can drag this 4 out. Remember, I can drag constants out through the integral, the whole integral, okay? I can take the 4 out of the integrand or whatever for fancy words. 4 integral of x e to the x squared minus 7. Now, exact same thing. I want a 2 there. I divide by 2, and that will become 2 integral 2x e to the x squared minus 7 equals 2 e to the x squared minus 7 plus c. Cool. All right, that's it for today. What we haven't done today, guys, which is what I'm a little bit excited about. Just remember, we're opening up the world of things that we can integrate. Okay, what we don't have here is something like this. If I go, let's say I've got integral of x e to the x squared. Okay, that's cool, that's fine, because if I derive this, it goes down a power and it's that. But what if that was that? This stuff I can't do yet, but we'll learn very soon. Think, yeah, we can get into trig as well, but we haven't done that yet. We'll do that next time. Okay, tuning out. You've got this. Thanks, guys.